Hi guys, welcome back. In this video and next few ones, we are going to understand the working of a deep neural network. I will avoid mathematics behind it, but I will try to show you the formulas which are used. But I will also explain them so that you understand the concept and develop an intuition, because that's what you essentially need in today's world. Thanks to technology, we don't need to be some mathematician in order to work with deep learning. It helps if we understand what's going on, and also there are interview questions from these concepts. So I will cover that aspect. So this is a regular deep neural network. Remember, if there are less than 3 layers, we consider them shallow neural networks and the functionality remains same. So this is a regular one, but even if it was a shallow neural network that is less than 3 layers, functionality will remain same. So let's say we are going to use this one for image classification. So this neural network will operate on those images and learn them. Now, to explain it better, let me use this picture of mine. You just saw it, right? But you haven't paid any attention to the fact that it is a very complicated process through which our eyes and brain works together to look at this image, or for that matter, anything we see. We take these things for granted. Trust me, it's a very complex process. This is easier to us. For us, it's just like looking at an image or anything else. But for computers, even today, with all this technology, their vision is far more inferior to ours. They can't see things like us. So how computers are going to look at it? Let's look at this. At first, in this image, here in the left, we can see that nothing is clear. Our model is not able to identify the features or anything. For any model in the world, at this stage, this image means nothing. They probably know that it's an image, but they don't know what it is, whose it is, what colors, shape, and those kind of things, the features of an image. So our deep neural network will work on this image, and with each layer, it will learn these features and get more clarity. As it proceeds from one hidden layer to another and so on, our model will learn the features like colors, shapes, etc. to know more about these images, or in this case about this specific image, and that's how it will learn. So with each layer it is going to learn more about it. But even at the end of its learning, after all the layers and all the training, as I have said earlier, its vision is going to be poorer in comparison of human. So don't even compare a human with the deep neural networks. Our vision is far more superior to these machines. And I guess thank God, otherwise we are probably going to deal with something like Terminator, right? So okay, moving on. But having said that, they are still very useful. They are used a lot in photos. Just look at these apps like Google Apps or iPhone's photo app, where it can identify a person and then group images together of that person. So they're also used in cancer detection. So their application is very wide. This particular technology is getting a lot of traction, and it's really a great opportunity for us to dive into deep learning, image recognition, and other application of deep neural networks. Okay, so now we know that our model will move gradually, and with each layer it will know more about these features and shapes and colors. But what exactly happened there? For that, you can look at this image. So if you see in this image, I have created these squares. Now, pardon my drawing, the shapes are not accurate, but basically these squares are representing pixels. For a deep learning model, entire photo, entire image is divided into smaller pixels. You might have heard about pixels in the context of camera. Pixels are like small squares which are building block of a photo, like cell to a human body. So our model looks at these pixels and not entire image to learn about these features. So here if you see, some pixels has got hairs, this area. So these pixels have got hairs. These pixels have got nose and portion of eyes. This one has got eye, some then there are lips, these are the shapes. So our model is going to cover all these pixels. So by learning these pixels, our model is able to identify this particular face. So if we were to supply a new image where I'm wearing a, let's say, a different t-shirt, or it's a full body image, even then also this model will be able to identify this face, this person correctly, because it has learned these features. So it knows that if this is the nose, this is the eyes, then this particular photo belongs to Akhilendra, or whatever name we decide. But based on these specific features, our model can correctly identify these images. And that's why they are so popular, because once we train these models on a certain set of images, even if we supply new related images, our model will be able to easily classify them. For example, if I were to change my face in some other direction, even then also it will be able to do that. So these models are really effective and they are really doing well in lots of industries. In this case, I'm using photo of a person, but it could be anything. It could be animals or tissue in case of cancer detection. But core concept remains same, where a model will first learn these individual features by going through these pixels and then put everything together. So this is the working methodology of a neural network. But what goes inside a neuron? To understand that, we are going to break this entire neural network to the smallest piece, where we have only one neuron and that's it. So I'm talking about this particular model. So here we have one neuron, one layer. There are two inputs here, but the layer is one and so is the output. And this is called Perceptron. You can consider a logistic regression model as a perceptron. So this is a single layer neuron where we are passing inputs to a single neuron, but we are not only passing input 1 and input 2 or whatever number of inputs we have. We are also passing two additional things to neuron, and they are called weight and bias. So you can see that two inputs are connected with two weights, and then there is a bias, and all of it is going into the neuron where we are applying an activation function on it. And I will talk about activation function later, but for now, this is the formula which you need to see. So here you can see that we are calculating Z, where we are adding Wx and B. So W stands for weight, X stands for inputs. So we are taking the product of weight and inputs and then adding bias. Weights are basically random values which are generated. So if you have already gone through my video on the neural network where I have used R, I have shown you that these weights are generated automatically randomly by the model. So these are random values. Bias is used because if weights are initialized to 0, product of weight and input will also become 0, which cannot be used in the calculation. Therefore, we need to add a bias to make sure that the output of this formula, that is Wx plus B, is never 0. So this value of Z is taken and then passed through certain activation functions. There are multiple activation functions like sigmoid, ReLU, which is ReLU, and few more, and I will talk about them while building models so that they make more sense. But for now, as far as methodology is concerned, you need to remember this, that whatever inputs you have, you are going to add weight and bias and then pass that through an activation function, and that's how we get output. So this is a single neuron, we call it perceptron, but when you add too many neurons, too many layers, even then also the functionality will remain same. That is, we will use product of input and weight and add bias and then pass it through the activation function. You don't need to memorize this formula, but you need to understand what's going on there because it's very important. So I think that's it for now. Now I will start with model building so that we can cover remaining concepts while building the model itself so that things are more clearer to you. But whatever I have covered so far, it's very important. Don't ignore it. A lot of time questions may come from this portion as well. So please don't ignore this. See you in the next lecture. Thank you.